Good afternoon, everyone. My name is Paul Mass, and I'm an application engineer here at Ally PLM Solutions. I'd like to welcome you to this afternoon's Lunch Bytes webinar, where we're going to explore some capabilities of the sheet metal application within the NX CAD software. Here at Ally PLM, we like to keep end users up to date on the latest developments with engineering software. We feel that afternoon sessions such as this one offer a perfect conduit to do just that. The Lunch Bytes webinar series is designed to explore capabilities within NX that are often overlooked. Future sessions will be delivered once a month, usually on the second Thursday of each month at 12:30 p.m. Eastern Standard Time. Previously recorded sessions can be found on our website at www.allyplm.com. There you will also find upcoming Lunch Bytes topics and dates. We want our Lunch Bytes to be valuable to you, so please let us hear your suggestions on the topics we should cover via email. We have several of you on the line today. Therefore, you'll be in listen-only mode. Should you have any questions regarding today's material, feel free to write them down and email them to me directly at paul.mass@allyplm.com. Sheet metal is used in a variety of different industries, such as electronics, aerospace, automobile, and HVAC, to name a few. NX has incorporated the sheet metal application to aid in the design and manufacture of the products used in these industries. The user-friendly interface of the sheet metal application will allow designers to create and edit sheet metal models with ease. The sheet metal application is a powerful tool that will help increase production and efficiency within your company. As far as today's agenda is concerned, I'm going to begin by showing how to access and set up the sheet metal preferences. Then I'm going to jump right into the software and work through 3 different examples. While working through these examples, you'll get an idea of how to navigate the sheet metal toolbar and an overall understanding of what a workflow for creating a sheet metal part might look like. Before I get started in the actual creation of a sheet metal part, I'm going to configure the default preferences that will be applied in the sheet metal environment. To do that, I'm going to come up here and create a new file. I want to make sure that I select the type of units I want to use. For this example, I'll be using inches. I want to come down here and select the NX sheet metal part and select OK. Now for setting up the preferences, I just want to come up here to the Preferences drop-down toolbar, and at the very bottom you'll see NX sheet metal. A few things to notice while under the Part Properties tab are we can set the material thickness. We can select the default bend radius. For this example, I'm going to do twice the material thickness and set that at 0.2 inches. Here I can also set up the relief depth and relief width. That'll become more apparent as we work through the stuff. As I add a flange, the NX application will automatically apply reliefs. This is where I can define the parameters of those reliefs. I can also set my neutral factor value, also known as the K value. This value is used in calculating the flat pattern of the sheet metal part. Under the Flat Pattern Treatments tab, we can apply automatic treatments to the inside and outside corners. I can have the sheet metal application automatically apply maybe a chamfer or a radius, but for these examples today, I'm just going to go ahead and leave it selected to none. Under the Flat Pattern Display tab, I can choose the line font, the line type, and the line weight and color that's going to be used in the drafting mode. When I go to add a flat pattern view onto my draft, this is where I could set preferences for how those lines come in over my drawing. Unfortunately, we won't have enough time to get into the 2D drafting environment as far as sheet metal is concerned today. We'll just be mostly in the 3D world. Under the Sheet Metal Validation tab, I can specify some more preferences about minimum tool clearance and minimum web length. I'm just going to go ahead and leave that set to the default values and select OK once I get done with my parameters, once I'm happy with those. So you'll see I'm here in a blank part. The toolbar we're going to be looking at today is up here towards the top of my screen. This is the sheet metal toolbar. We're going to start with the tab command. It's the very first thing I need when starting a sheet metal part. It's my base feature. I go ahead and select the plane I want to draw on, and I'm in the sketcher mode right now, and I'm going to go ahead and use the profile command to just come in here and rough sketch a shape, maybe a rectangular shape with a semicircle at the top of it. Maybe I can come in here and apply some constraints, and then apply some dimensions to give my shape some parameters and more defined. I'll give it a width of 8 inches and maybe an overall height of 12. And go ahead and select Finish once I get the shape of my base tab. You'll see that the NX sheet metal application has automatically applied the material thickness that we specified in Preferences. I'm going to go ahead and select OK to start the part. The first menu I'd like to cover is this Flange, or what's also known as the Bend drop-down menu. Here we get to cover different types of flange, whether it be a basic flange, a contour flange, a lofted flange, or a hem flange. I'm also going to show the bend command and the jog command. So let's get started by just adding a flange to one of these edges. The first thing I do is I pick the edge that I want it to be applied to. Some things to recognize under this flange menu is that we can apply this flange across the edge for its full width. We can select it to be at center. At the end, what it's going to ask me is which end do I want to apply that flange. I can do from end, or I can do from both ends. Another thing that I really like about this application and NX in general is that I have the ability to come out here into my graphics window and grab these handles to adjust for the length of the flange. I can adjust for the width of the flange, or in this instance, how the distance I want it to be from the end. I can also adjust the offset of the flange, and I can adjust the angle of the flange. Or I have the ability to come over here and key it in under the flange menu. For this particular flange, I want it to be the full width across that edge. I'll give it a length of 4 inches. I want it to be at 90 degrees. I'm going to have the material outside, and I don't want any offset. The inset refers to where the material will end up in relation to the edge that I picked. So they have some little diagrams down here underneath the insert selection. Basically, it's pretty self-explanatory. Material inside means that the material thickness is going to lie on the inside of that selected edge, or I could put the bend outside so that the bend tangent lies at that selected edge, or material outside. I'm going to go ahead and leave it for material outside and select OK. So there is pretty easy just to add a basic flange. Now let's say I didn't want this flange to be rectangular in shape, that I wanted to edit the profile or the sketch that creates that. All I have to do to edit that flange is double click, and I can come up here to the section portion of the flange menu and click on Edit Sketch. Notice what it does is it brings me into the Sketcher utility, and I can simply just come in and just start drawing lines to edit the profile of my flange. Maybe I want to create some type of circular cutout over here. I can come back through with the trim tool. One thing I really like about the trim tool is I can either pick lines, or I can use the draw mode, and basically it comes through and draws a pencil, and I get to chop off whatever I don't want with this trim command. One little tip there for the quick trim command. And maybe I want to go ahead and add some blends in here, or fillets. Once I get done and I'm happy with my shape, I could add other dimensions if I wanted to, but I'm okay with that for this example. And notice that it automatically updates. It adds our bend back in. Now I have the shape of my flange. I'm going to go ahead and select OK. Now let's say I wanted to add a flange on this side. This particular flange, I'm going to use the from end. I have to specify which end I want to measure from. I can key in my values, maybe a distance of 1.5 from that end. I can give it a width of, let's say 2 inches. And maybe I want it at an angle of 70 degrees. I can also edit my depth and width reliefs for the reliefs. Notice here When we were looking at preferences, we were talking about that reliefs will be added for flanges during flange creation. I could edit that stuff here, but now this is where the default values that we saw under preferences come into play. I can also choose to have a round relief or choose none. This is typical when we're dealing with thinner sheet metal, that maybe we just want to have a tear condition. But for 0.1 inches, I'm going to go ahead and keep it a round relief. And go ahead and select OK. So now let's say we have a flange that's already been created and we want to add a bend to a pre-existing flange. I come up here to the same drop-down menu and choose the bend command. And it's going to ask me which face do I want to apply this, where do I want the bend line to lie. It's going to take me, I select the face, it's going to take me back in the sketcher, and really all I need is a line to define the bend. So I can just come in here and draw a line anywhere. Notice that I had my point on curve snap selected so that it would select the edge of that flange. I've defined my line. I'm going to go ahead and hit Finish Sketch, and notice that's where it applies the bend. Currently I have it set, the inset set to the bend center, so the line that I selected is at the bend center. I can choose that to be the inner mold line or the outer mold line. One thing I really like about this the sheet metal application is that I get to see active live feedback on the screen as I'm making adjustments to my model. I'm going to go ahead and select OK. The next command I'd like to show is the Lofted Flange. I come back up here to the same drop-down menu, the bend drop-down. I'm going to choose Lofted Flange. And the things I need to define a lofted flange are a start section and an end section. The first thing I need to do is establish where this sketch or where this section is going to be placed. I'm going to do it normal to this curve. Notice it throws a datum plane in there, and say I don't like the orientation of my CSIS. All I have to do down here is go ahead and select my horizontal reference. I want my X to be in that direction, and now I have X pointing out to my right, Y pointing up, and Z coming out at me. Once I'm happy with the orientation of the CSIS, I can select the position of where this sketch or where this flange is going to start. I can choose to have it set to arc length. Basically, it's saying that that section is going to be 6.9 inches away from the end of this arc. If that's the start, I'm out 6.9. I can also choose to have it be a percentage of that arc length. Maybe I know I want it to be at 50%, I want it to start in the middle, or I can specify through point. I'm going to go ahead and leave it on arc length and choose OK. Notice it brought me back into the sketcher mode. I'm going to stay on the profile command and start my section at the origin of that CSIS, and I'm just going to key in values. Maybe I want my first line to be 4 inches long at 300 degrees, and my next line to be 2 inches long at 0 degrees. Select Finish when I'm done with my first section. Now I need to follow the same process for the end section as well. Come here and select my horizontal reference, select OK once it's oriented the way I want it to be, and then come in here and draw my section. Maybe this time I want it to be 2.5 inches long at 300 degrees, and then 3/4 of an inch at 0 degrees, and hit Finish. Notice that it's automatically transitioned from the start section to the end section. In regular modeling space, this would take much more effort to produce a similar result. It's a powerful tool, this sheet metal application. I really like it. I wish it would have been around back when I was in configs design in the aerospace industry. That's what I did day in, day out, was create sheet metal brackets and tubing that run on the outside of a jet engine. We would have really killed to have a piece of software like this. I'm going to go ahead and select OK to create that flange. The next flange I'd like to create is what we call a contoured flange. It's similar to the lofted flange in that I need to specify where I want my sketch. I'm going to come down here and select my horizontal reference. Notice the X is pointing to my left right now. When my view is oriented like this, I really want it to point the other way, so all I have to do is double click on this vector. Now I have my CSIS oriented the way I want it to be. I can drag it to the end of that arc and select OK. Brings me back into the sketch mode. I'm just going to roughly sketch in some type of section here for this example. I'm not going to really specify any types of dimensions or anything of that nature. I just want the cross section of what this profile is going to be. And I come up here and hit Finish Sketch. I have different options available to me. I can, for the width, finite would allow me to choose a specific width. Symmetric would go in both directions. To the end would put it to the end of that arc. Or for this example, I'm going to use the chain command so that I can choose the arcs and lines that I want that section to follow. I can bring it all the way around. Really awesome to look at. So you'll see just in a few commands we've gained some pretty good ground here. I mean, it would have, like I said, it would have taken much more effort to create something this complex, and we're only a few commands deep. Some of the other commands I'd like to show are the jog command and the hem flange. I'm going to first start out by adding a flange at center down here to this edge. Again, I can just use my dynamic handles and get live feedback on the screen to where I want this to be positioned. I'm going to go ahead and select OK. Maybe I want some type of hem flange out at the end of this tab. So I'm going to come up under the same drop down and choose the hem flange command. And then I want to pick the edge. The edge that I pick, the hem will be applied in the upward normal direction. So if I apply it to this, it's going to shoot down. If I apply it to that, it's going to shoot up. The options we have available in this package, there's many different kinds. We have a closed hem, an open hem, S-type, a curled hem, an open loop, a closed loop, a centered loop. Lots of different stuff available to us there. I'm just going to go ahead and select the open loop. Down here I can specify the diameter or radius that I want that loop to be. Maybe I'll give it a parameter 0.3 inches, and maybe I want it to sweep 160 degrees. I'm going to go ahead and select OK. So now I have this tab out here with the little open looped hem flange at the end of it. Maybe I need to offset this normal to the face. Maybe I want half of this to be maybe 1/4 of an inch higher, 1/2 of an inch higher. The command I'm going to use for that is the jog command. It's similar to the bend command in that it asks me which face do I want to apply it to. I'm going to come down here and select my face. It's going to bring me back into the sketch mode. And then I just need to draw a line where this jog will be created. I'm going to go ahead and hit Finish Sketch. And you'll see that it jogs that up. Maybe I need it to be 1/2 of an inch offset. Or we could do 3/4 of an inch. I'm going to go ahead and select OK. Maybe we don't like this sharp corner down here. I can go ahead and use the chamfer command. To break that sharp edge. I can apply maybe 1/4 of an inch chamfer. Select OK. So there's the different types of flanges we have available to us, and that pretty much sums up my first example. The second example I'd like to get into is I want to cover corner treatments, a closed versus an open corner, the different types of relief types we can apply to a corner where two bends meet. We can apply a circular cutout, a U cutout, or a V cutout. I did just show one example of how to treat sharp edges with the chamfer. On this example, I'll show how to treat sharp edges with the break corner, which turns out looking like a fillet. And then I'm going to show you how to create a normal cutout or create an extruded shape in the flattened state. Jump right back in here. So what I have here is a piece of piping with the flange at one end and a boss at the 12 o'clock position at the other end. And I've created the beginning of maybe what a bracket would look like. I created a sketch with a base tab here and then added a flange to the top and 3 flanges around the sides. Notice where these flanges come together, there is a gap that eventually would need to be welded to make this bracket more stout and sturdy. We really wouldn't want that gap there in this case. So I can come up to this corner drop-down menu and choose the close corner command. And then I'm just going to go ahead and pick the bends that I want to be closed up. I can just have it apply a relief, which will maintain that gap. But in this instance, I do want to apply a close and relieve. If I leave the corner treatment to the open selection, it just gives me my standard relief where the material is cut away for the bend. I can have these two overlap. Notice that the flanges meet to where the vertices kind of meet at a point there, and then this is where my weld would be. Maybe I want to have those overlapping, and then I also get an overlap ratio. If I set that to 1, I'm going to get the overlap for the full material thickness. Maybe I just want it to be 25% of the material thickness, so I can still put a weld there, and now my weld maybe won't burn through. I'm going to go ahead and select apply. By choosing OK, I'm going to come out of the command. If I just select apply, I can continue to apply more closed corner treatments to these other corners. Maybe on this one we want to give it a circular cutout. The things available to me here is that I can control the diameter. Again, I get live feedback showing me as I make changes. I'll leave that at 3/4. I can also apply an offset if I want it to be a little bit further away from that corner point. I'm going to go ahead and leave that at 0. You know, when I was designing sheet metal brackets, I was always taught that the relief should clear the bend tangent. So that looks pretty good to me. In this case, I don't want there to be any overlap, so I'm going to come back up to just closed and select apply. And I can follow this same method through my front corners here. Maybe I'll give this one a U cutout. Maybe I'll come over here to this one and select the V cutout option. In my V cutout, I can adjust the angle. You'll notice I have control over you know, whether I want to control those angles independently or whether I want them to be the same. I can go ahead and select apply. Now I applied a different corner treatment to each corner, and I would like to take a look at that in the flattened state. So we can see here it becomes pretty obvious how the corner treatments differ. The one in the lower right-hand corner is going to be our open treatment. The one in the left will be the circular. Upper left will be the U cutout treatment, and the one in the upper right is the V cutout treatment. Pretty nifty stuff. We used to literally have to come in here and create a sphere. Back when I was in the formed state, you know, we would have that box, and I would have put a sphere at that point and did a Boolean subtract. And it was a lot more work, so the software has come a long way since version 18 or NX2 when I first got introduced to it back in, when was that, 2003, I think. I'm going to do some undo to get rid of that flat solid because I don't need it. So now we see that this our brackets coming together here. We got our corners set up so they can be welded together, but I do need to come out and somehow attach onto this boss. I'm going to come in here and add a flange at center to this edge. I want the width to be 1 inch because that's the size of my boss. I want that to match. I don't want it to have any offset just yet. And I want it to be at 90 degrees. Notice that obviously I need to come down a bit, So this is when I am going to use the offset. I'm going to reverse my vector so that the offset's shooting down. And one thing that's really nifty, one thing that I really like, is that I can just come out here and right click over top of my offset vector and do snap to object. And I can select the arc center of my boss. And it's going to automatically snap it to that level. Notice that they're, at the moment the tab is clashing with the boss. This has to do with my inset. If I select that to material inside, it's going to move it so that the face is placed on top of the boss. I can also do that with my length. I can right click over it and do snap to object. Make sure my arc center snap is turned on. Select the center of that boss and it's going to snap my length. I really like that I don't have to do any calculations. I don't have to measure a distance. I can just right click and do snap to object and my design practically falls together by itself. Notice that I do need a little bit more material here though if I expect to put a bolt through there and connect onto that boss. So then I can just come back up here and edit the sketch. Just go ahead and throw a circle in there real quick. Trim away what I don't need. Hit finish sketch. Everything automatically updates for me. I'm going to go ahead and select OK to create that tab or that flange. One thing I need to add still is a circle or a hole to punch through there and get down into that threaded hole in the boss. As a personal preference, I'm going to go ahead and use the extrude. You could use the hole command that is available to us in the sheet metal application, and we'll get to look at that later on in a later example. I'm just going to go ahead and choose extrude. Create a circle there. Maybe apply a diameter of 3/8. I'm going to flip my vector in the other direction because I want to push it through the bracket. And then I can come down here and select the body that I want to subtract it from and choose OK to complete the command. So now we're set up pretty good here for I had a clearance hole for my bolt to go down there and catch into that 1/4-inch threaded hole. Notice that this tab we created out here has some sharp edges. We want to break that or put some type of blend in there so that's a smoother transition from that forward flange out to that tab. I can do that by coming to my bin drop down or my close corner drop down menu and choose the break corner command. Then I just come in here and choose which corners I want to break. 1/4-inch looks good, so I'm going to go ahead and leave it that way. Select OK, and now we see we have a smooth transition to get out there to that tab. So at this point, our bracket is looking pretty good, looking pretty sturdy. Didn't take much effort at all on our part. But maybe the component that sits on top of this bracket needs some type of clearance through this back face and this top flange. Maybe it has some hosing that attaches to the bottom of it or something like that. We need to create a cutout there. For that, I can come in here and use the normal cutout command. First, I need to define the datum plane that I'm going to sketch that cutout on. I'm going to come in here and create a plane at angle. It's got a little bit of an offset to it. I'll select OK to create my plane. Now I can do my normal cutout. I go ahead and choose the plane that I just created, the datum plane I just created to create my sketch. And maybe I'll just come in here and draw a rectangle. Select Finish Sketch. Now what the normal cutout command does is it projects the lines of my sketch down onto the shape of my bracket, and wherever those lines end, then it cuts normal to the face where those lines were projected. Pretty sharp tool. So that would be one way to create some type of clearance feature that wraps over a bend and goes through a couple different faces of my bracket. Let's say I don't have the luxury of creating a plane. I know what my shape is going to look like in the flattened state. I can do that as well by unbending one of these bends. First, it's going to ask me what my stationary face is going to be. Then it's going to ask me which bend I want to unbend. And go ahead and select OK. Now I can come back down and use the extrude command. Maybe I want to come in here and just sketch a circle that's going to shoot through that bend. Again, I want to flip my vector to push it through the bracket, choose the bracket and subtract from that, select OK, and then I can rebend, apply a rebend command to that bracket and put it back in its formed state. So in the second example, we got to examine some pretty powerful tools. We got to examine how to close a corner with the close corner command and automatically apply corner treatments and reliefs. We got to look at some break edge or break corner command. We also got to look at unbend, rebend, things of that nature. For my third example, I wanted to show some deformation tools. The dimple, the louver, bead, and gusset. Deformation features such as a gusset or bead can be used to make a sheet metal part more rigid or to add strength. The dimple command can be used to create clearance for a nearby component that would otherwise crash into the part without a dimple. And a louver is often used to aid in airflow and to dissipate heat. So we'll go back into the NX here and create some of those things. I changed some colors around just to try to keep you guys interested. I got that pretty light blue down there, and so we could get a little bit of, we can see what part is the bracket and what part is the flange. So in this case, we don't have the luxury of creating side gussets here. Maybe there's some routing of pipes that are passing underneath there, or some other components in the area, and we need this bracket pretty much just to be at an L shape. But if we leave it like that, we know that it's not going to be a sturdy bracket. So within the sheet metal application, they've included some deformation tools such as the gusset, and all I have to do is pick on what bend I want, and it automatically has, it comes in and forms that shape for me. I get to see it's pretty to look at. I can have it be a square gusset or a round gusset. I get to control the depth. Maybe I want it to be at 0.7 instead of 0.6. I get to control my punch radius and my die radius. There's things there that are available to me. The placement type I have set to fit. That way it automatically calculates the distance between the gussets and the distance from the end of the first gusset and the opposing end to the second gusset. Let's go ahead and select apply and complete that command. So now we can see the top edge, top end of our bracket, this cantilever beam that's kind of sticking out here. It won't be so flimsy, kind of, maybe we could put a little bit of weight up there now. But we still have the second part of the base tab of this flange maybe could flap in the wind or might be wiggling back and forth due to vibration. So in order to add some rigidity and strength to that, I'm going to apply some beads to this back face. Under the same drop-down menu, I can choose the bead command. Really the only thing I need to create a bead or place a bead are a couple of lines. So it's going to ask me on what face do I want. It brings me back into the sketcher mode. I'm just going to draw a couple lines here. I go ahead and it throws those those beads in there. We have some different shaped beads available to us. I could use a circular bead or a V-shaped bead or a U-shape. I have end conditions that I could set. Currently, we're viewing the punched end treatment. I could do lanced, where there's no gap between the end of the bead and the punch, or I could do formed. Before, we looked at another command that also had the options to specify die radius and punch radius. If you could imagine when this bead is being punched, the punch is the one that's going to push the bead down into the material. So it would be this blend here towards the external face of the bead. The die radius is this internal. So I do have the ability to adjust those. I'm going to go ahead and select OK. So now my bracket's a little bit more sturdy. Down here I just created a circular base tab. Maybe we want to put an end cap at the end of this flange. If we want to match that bolt pattern, we can come in down here and put a design feature in. Those are still available to us in the sheet metal application. We still have some of the regular, what you would normally see in the modeling atmosphere or application. So I'm just going to come in here and put a hole. I'm just going to specify the location of one hole, then I'm going to pattern it around to match the bolt pattern. All I need to do is apply a constraint to my point. I want it to be at the inner center of that arc. Make those coincident. My sketch is fully constrained, and I can hit Finish Sketch. Diameter of 0.5 is fine for me. It automatically picks up which body I want to subtract it from, and I can select OK. Go back to the shaded mode here so you can see what's going on. Now obviously I want holes all around it, not just one location, so I can come in here. Again, these are what you would normally see in the regular modeling atmosphere. I can come in here and do an associative copy, instance that feature. I want to do it in a circular array of that hole. I know that my bolt pattern, there's 12 of them, and for my angle it would just be 360 degrees divided by 12. I'm going to select OK. It's going to ask me at what point or what axis do I want to rotate about. I can come in here and choose my Z axis and create that instance. So now maybe at the end of this end cap I want to put a dimple. Again, that was in the same drop down where we were doing the bead and the gusset. I'm in the dimple command. I got to come in here and sketch the profile of my dimple. Maybe it's just going to be a simple square or rectangle. Currently it's at a depth of 3. I can drag it, or I can enter it. Maybe I want it to be at 0.2. I can choose whether I want the material to fall inside or outside of that profile that I sketched. Again, we have some of the same options available to us. I'm going to go ahead and select OK. Maybe I want to put some louvers at the end of this end cap. What I need to do, I came in here and selected the louver command. It brings me back into the sketcher mode after I select my face. And now all I need to do really is just draw some lines to create my louver. One thing I do want to show here is I'm going to draw multiple lines as if I were placing multiple louvers and hit Finish Sketch. You'll notice that it only placed one of the louvers. While in the louver command, it will consume this sketch. If I hit apply here, notice that the sketch was consumed and I'm unable to pick the lines and apply other louvers. I'm only able to apply a louver to one line at a time. So if I wanted to apply multiple louvers on a surface, I would create my sketch first, keep that sketch external from the louver command, come back in here and draw the same lines. Finish that sketch out. And now I can apply multiple louvers to that face just by staying in the command. I'm going to flip my direction around there. Notice how easy it is to, you know, if basically all I was doing is I saw that my louver wasn't oriented correctly, so all I have to do is reverse the direction. Just one button. If I wanted to push it onto the inside of the face, I'd reverse the direction of the depth. If I wanted to reverse the direction of the width, all I have to do is click it. And then I can hit apply, choose my next line, apply, choose my next line, hit apply. So those are the deformation tools available to us in the sheet metal application. Really powerful tools, easy to use, and they look pretty on the screen. You know, I didn't have to do any fancy modeling. You know, pretty impressive stuff. So those are the 3 examples I had to show to you today. Again, I want to thank you for your attention this afternoon. I hope you found this session informative. Feel free to email us any questions that may have come up during today's session, or if you have any suggestions for future Lunch Byte topics. And if you ever feel like the dog in this picture here, feel free to give us a call on our technical support line. You can reach us via email or phone call, and we'll be here to help out with any way we can. As I mentioned earlier, previous Lunch Byte sessions are on our website. A replay of this Lunch Byte will be up shortly. If you missed something or if it went by a little fast, just check back and you can view it again at a later time. Join us for our next session, which is going to be on July 12th, where we're going to be covering assembly constraints. Also, this summer we're having a special on NX training, so if you have any questions regarding that, you know, we have a training facility here on site. You can come out and visit with us, and it's always fun to learn more stuff about the CAD world. So thanks for your time this afternoon. I had fun. I hope it was informative to you, and we look forward to seeing you again.